Okay, let's look at this problem. Count the number of incremovable subarrays 2. So the first problem of it was quite on easy level where we have lesser constraint. So that there the constraint was just 50, and here we have 10 to the power 5, which is the length of the nums can go up to 10 to the power 5. So we can try order n log n solution or order n solution. So we will actually look both of them. Order n log n will be when we use binary search, and order n solution will be when we use two pointers or sliding window technique. So let's define the problem. So we are asked to find the number of incremovable subarrays. So how do you define incremovable subarrays? So um, that is when you remove a subarray. Let's say when we remove this subarray, and after removal of this, if we get a increasing, which is strictly increasing array, then we can say that this is one of the possible incremovable subarray. So we have to count how many subarrays of this kind can be possible. So the brute force approach was simple, in which we have to find a subarray and then remove it, and then iterate over all the elements except in that subarray and check if it is strictly increasing or not. So that was order NQ. So let's see how we can reduce that. So one observation is that the number of increasing array possible, that is after removal of incremovable array, means another way to define this problem is we have to find the number of increasing array possible after removal of incremovable array. So how can we remove this subarrays? So there are in total 4 types of removable possible. So let's say if we try to remove the subarray from right end, then the remaining array will be this, and we will check if this is strictly increasing or not. Similarly, we can remove from the left end. We can also try to remove from the middle. So these are only the 3 possibilities which is possible, because subarrays are contiguous and you have to keep them together. So we can only remove from left end, right end, or in the middle. One more possibility is when you try to remove all of the subarray, and it is given in the question an empty array is also considered increasing. So that is also the case which we have to keep in mind. So what all possible cases have arrived? One is when we remove from right, then left, then middle, and if we remove all the elements in the array. So we have to check for that case. So now let's assume that we have removed these 3 elements from the right. So is this increasing? No. So if we remove this, then is it increasing? No. If we remove this, then is it increasing? Yes. So we have to find a index starting from the left and going to the rightmost increasing index, after which it won't increase further. So in other words, we need to find the rightmost index till which it is sorted. So if we have found that index, how can we know that what will be the number of um, incremovable subarrays? So we have to find increasing array possible after removal of this subarray. So if we remove this, then one possible answer is 3, 4, 5. If we remove this, then one possible answer is 3 4. If we try to remove this, then only 3 is left, and 3 is also increasing. So after we have found the index, let's say L, the answer would be the number of elements till L if we try to remove from the right end. Similarly, if we try to remove from the left, we will find the in the rightmost index from which it is strictly increasing is this one. So let's call this R. And how do you calculate the number of this subarrays possible? Is just how many elements are there on the right. So if we remove this, then it is strictly increasing. If we remove this, then this 6 is strictly increasing. So we have covered this left and right. Let's look at how to deal with the deal with the situation when we remove from the middle. Now if we remove from the middle, um, let's actually remove it and see what happens. So if we remove um, this from the middle, then we have to check what all possible increasing subsequence can be formed. So how we will check? We will start looking from the left, uh, and then check how many if what is the next possible uh, s- in number which we can take from the right. So can we take 2 to make it strictly increasing? No, we cannot, because 2 is less than 3. Can we take 4? Yes. And once you take 4, you will look that we can also take 6 from this end, because all the elements to the right of the first index which is greater than 3, all the elements can be included in the subarrays. So in other word, if we know only the first index from where this will be left greater than the left, we just need to add all the numbers to the right of it to find all possible increasing subarrays which we can form. Basically, if we take 3, we have a possibility of finding 3 3 4 6 and 3 6 as our answers. So these are the all possibility when we find one index which is greater than the left. So how can we store that in an answer? We can, let's create answer variable and then add n minus r to that answer for each of the I index which is going from I1 to left. Left is the leftmost greatest element if you which is sorted. So this is, and how can we find this r? This r can be found by using binary search. So this will give us order and log n solution. We can also see um, order n solution by using 2 pointers. Basically, we will have one pointer set here and one pointer set here, and we will check if this 2 is greater than 3. No, it is not. Then it will move to the right. If it is if 4 is greater than 3, yes, so it is one of the answer. Then we can move to um, then similarly, as we have searched seen in binary search, we can just add a +2 here because this is increasing. Now we have found for 3 all possible cases. Now we will move to next index 4. For 4 we will see what all are increasing. We find only one answer, which is 6. So we will add +1 here, and then we will increase left. We will reach 5. And then again we are at index 6. We will check if this is increasing, then is more than 5. The answer is yes, then we will increase 1. So basically we will have 4 plus 4 as our uh, answer for when we remove elements from the middle. And all, if we remove all, then we can just add plus 1 to our answer. So let in summary, if we remove from right, we have to count number of increasing array from left. Similarly for left, number of increasing array from right. If we remove from the middle, we will have to look from left and right and find all possible subarrays. And if we remove all, we can add just plus 1 for an increasing subarray. So now let's look at the code and see how can we implement it. A variable n which will store the size of the nums array, and then we will declare two variables. Let's name them left and right. So what are these variables? So these will be used to store the largest value of the element of nums, for which all the elements from index 0 to that left will be strictly increasing. Similarly, in right, we will store the index of the right most, means the smallest index, for which all the elements from n minus 1 to right will be strictly increasing. So how to calculate that? Let's look at this loop. Let's increase this. Let's start this loop from 1, and this will go to n, and increasing I for each iteration. Now we will check if this element is possible or not, if this element is strictly increasing or not. So nums I is greater than nums I minus 1, then this is one of the possible answer. So we store that in I. Whenever this condition break, we also break from this loop. Similarly, we can calculate for right index. We will start from n minus 2, go till 0th index, and what we will check here, if nums I is less than nums I plus 1, then this is a possible candidate, so we will use it for right. Whenever this case breaks, we also break from this loop. Now since this answer have to be long, we will declare our answer also answer in long type, and then we can go to our logic part. So let's first see how to do this in using binary search. So what we have to do is to iterate. So we know the answer for the left and right when we remove from the right of the array, and when we remove from the left of array, that will be just left plus 1 and n minus right. So now we will look at the how to find the number of arrays when we remove from the middle of the array. So iterating from I is equal to 0 to I less than equal to left. Left is the highest index till which it is strictly increasing, and then I plus plus. And for each of this index, we will check the number of possible elements on the right of it to form a array which is strictly increasing. So let's declare it using R upper bound nums dot begin nums dot end nums high, and then subtract it from nums dot begin. This will give us the index for which we can find the strictly increasing array, taking the element from the left, and then we can add it to our answer. We have seen why this should be n minus r. Okay, now we have answer, we know the left and we know the right, means answer will store in the middle. So let's name this mid actually, and then plus 1 will be the case when we remove all. So let's return mid plus left plus 1 plus n minus right, and then plus 1 for the case when we remove all. Let's check. Oh, I missed this bit. Okay, yeah, you see that this passed for these two cases, but it didn't pass for this one. So we have to also include one edge case here. That is when all the elements in the nums array are strictly increasing. So when will that happen? That will happen when the left, which is uh, the largest index till which the number is strictly increasing, is actually n minus 1. Then we can return n into n plus 1 LL. L is a long form of 1 because we need the answer in long form, divided by 2. Now let's check it. Okay, why 2n plus 1 divided by 2? So if you look at this whole array, you will see you can take individually 1 1 1 1 2 3 4. Then we can take a window of 2 and then slide 1 2 2 3 3 4, and then take window of 3 and then slide. So this, when you add up, will be equal to n into n plus 1 by 2, which is the summation going from 1 to 4. So 1 1 2 3 1 1 2 1 2 3 and 1 2 3 4. So that's 1 plus 2 plus 3 plus 4, and the formula for that is n into n plus 1 by 2. Okay, so this was using binary search, which will be order n log n, because we are going from 0 to left, and left can be in worst case till n, and upper bound will use log n to search for that element, so n log n. Now let's look at how we can do this using two pointers. So let's declare our pointers using L and R. L will be 0, int R will be right. Left will start from 0 and R will start from the right index. So while, let's check for the bounds. L is less than equal to left and end. R is less than n. Then we can check if nums R, which is the index at the right, is greater than nums L, then we can add it to our answer. For the leftmost index, what all possible arrays can be formed from the right? uh, that will be n minus r, and then we can increase left to check uh, the next index from the left array. And if this case is not possible, then we will check for the higher number on the right. So we will do r plus plus. Now this should give us the same mid. Okay, this should be mid. Let's check. Yes, it passed. Let's try for all cases. It got accepted. Thanks for watching.